So basically, in the last class, we discussed about data warehouse. Data warehouse is nothing but it stores all the historical data. We have differentiation between database and data warehouse. The naming convention is same, like we do use the same naming convention for Oracle, SQL Server, Teradata, Netezza, all these databases, right? So we do call it as databases. But database is also the same Oracle. We do call Oracle as database or data warehouse. But the differentiation is we have a proper differentiation by making use of the OLTP versus OLTP. But in general, data warehouse, it stores all the historical data and
Mm-hmm.
basically like it is subject oriented, time variant, non-volatile and integrated systems.
Mm-hmm.
So we have seen like OLAP is nothing but online analytical processing systems, which is we are going to do some analysis on top of existing data. So, and we also differentiated what actually OLTP system is. OLTP systems are nothing but it's a real-time systems, or we can also call it as source systems. Okay. So basically, we can also we are going to get the source in the actual data by using these OLTP systems, or we can also call it as application-oriented systems. So in terms of the life cycle of data warehouse, yes, we have databases like OLTP systems, and we do have an ETL team, which they are going to take care of this data loading part, and they're going to load into data warehouse. So we might have a number of applications, okay, any number of applications. So then they are going to track like each and every application information is going to track in individual databases, and or sometimes we are going to get the data. Sometimes we do get the data from the business. They're going to share the CSV files to the ETL team. Anything is fine. So, but anyhow, they are going to capture the data by using some applications. ETL is nothing but extraction, transformation, and load. So they are going to extract this data daily, or it depends on the time zones, every day, or maybe sometimes weekly, or sometimes 3 times a day. It depends on the importance of the data. So, but mostly on a regular intervals, like every day, they are going to extract this data. Importantly, they are going to do some transformations, and they are going to load into one single database that is called as data warehouse. So data warehouse in general, yes, it stores all the applications, like collection of all the application. That's what we say, like subject oriented in the sense, collection of all the applications. And it is time variant. Time variant is nothing but, as we discussed, it is going to store all the historical data, correct? But basically, if you have historical data, the advantage is you can go for comparisons. That's what we discussed earlier. We can compare the data like current year versus previous year, something like that. Or we can compare last 6 months of sales. So if you have historical data, you can compare the data like current year versus previous year or year over year, so that it helps a lot for better business analysis. This is very important point. For better business analysis, we do go for comparisons, right? And in OLTP systems, basically it won't store maximum 30 days or 30 to 90 days of data. In real time, you can see we are going to get daily files from the business, but maximum OLTP system stores 30 to 90 days of data. That is the reason why we don't prefer OLTP systems in reporting, because it won't store complete information. And even this is only one application data, because we have to showcase multiple information in reporting side. That is the reason this subject oriented is very important. Like we have all the applications, all the application related data available in one single database, that is data warehouse. So this is what we discussed earlier. So I'm going to showcase what actually non-volatile and integrated. So let me know if you have any questions on this, like subject oriented and time variant. Subject oriented, as discussed, it's a collection of all the application in one single database. And time variant, it stores all the historical data. So it helps a lot for comparison between any particular information, like let's say mostly like current year versus previous year, or current quarter versus previous quarter, something like that.
So what do you mean by non-volatile and integrated? I think I forgot what that means.
No, we are going to discuss that. So
Okay.
non-volatile is nothing but non-volatile basically is like, just remember, so we have database access in real time, right? And on top of database, we can write a select statement. Okay. So we have an access to select statement. We can write a select query. I'm going to showcase that. So we can write a select query on top of databases, but we don't have access. We don't have access to, this is volatile database. We don't have access to write something like insert, update, delete, even insert. So what I mean to say is, for the database persons or for the ETL people, so developers, so they can insert the data. They have an option to go for update. They have access to delete, insert, select, everything. They have each and every access on top of database or data warehouse. That's what the point here. It's simply related to access or permissions, right? So we don't have an access to delete the data, okay, to delete or insert or update any part of data. Okay, so that's a functionality here basically. So remember, data warehouse, right? So these 4 points, if someone asks what is data warehouse, you can tell that, hey, this is subject
Hey
oriented,
can you help me
non-volatile.
with that charger?
So we have subject oriented, time variant, non-volatile. Non-volatile is simply related to access things. So on top of data warehouse, as a reporting person, as a Tableau developer, let's say we are a Tableau developers, and we can access, we can connect to database, and we can write a simple select star from table name to check the data. Okay. But basically, you don't have an option to create a table. You don't have access. You can write some create table logic, but you don't have access to the database or data warehouse. So if you need an access, you have to go for the permissions, but with a proper business reason. So that's what the restriction actually. So we have only for the select statement access. We are just going to use some select query to get the results, to check, to validate some set of data. But as a like backend developers like ETL or database developers, they have each and every access, like insert, they can insert, they can update the data, they can delete, they can select some part of data. Okay, so they can create. So that's what non-volatile, it's simply related to permissions or access related things.
Okay.
Okay, but integrated is important. Basically integration is nothing but do you know, like basically whatever the OLTP systems we are going to use, OLTP systems, it stores transaction related information, which is transactional processing systems. But as I said, it stores real-time data, or it's a source systems actually. So OLTP systems, basically it stores non-integrated, that is, which is in general, it stores low level granularity, lowest level of granularity. So let's say day level, right? Example, day level. So we do have data across the day level. Let's say you do some transaction, right? Let's say you have done some couple of transaction today, tomorrow you have one transaction, maybe day after tomorrow you have couple of transaction. So it's not like directly you are not getting any data across month level or year level. You have daily transactional data, and what is going to happen is integration is nothing but we are going to summarize or we are going to aggregate the same data across different level. That is what integrated. So one of the advantage in Tableau or even in any of the business intelligence, right? So we have functionalities, we have functions. So we can go for functions to create year, but even in the while creating the data warehouse, while pulling those data, like whatever the data they are going to extract, whenever they are going to move this particular data into data warehouse, they can also do some transformation. That's what I said, right? So they can create some calculations, and they are going to do some mapping tables, and they're going to do some formatting the data, avoiding some null values. So they can also create calculations while pulling those records into like data warehouse. While loading the data, let's say if they wants to create some part of data or like calculations, they can even do those calculations by making use of transformations. But integrated, yes, we have a functionality where you can save the data across day level or month level or quarter level or year level. In general, we have data only in the OLTP systems. We have data only across the lowest level of granularity, but integrated is nothing but you are going to showcase summarized data. You're going to showcase summarized data that is kind of an aggregated data. Let me showcase an example. This order date you can see. So based on orders, we are capturing the order date. So double click here. I will showcase the actual data. So this is what the order date. Okay. So this is a regular date, right? So you have this regular date format. But if you want to showcase the data across year level, so how many number of orders, let's say, basically count of orders you're going to get based on that particular order, how many number of orders like they are going to place across this particular day. So if you want, you have an order ID, right? So you have order ID and you can check the number of orders placed across that level. But what I mean to say is, if you want to showcase the same information across year level, one of the flexibility we do have in Tableau is you can drag and drop order date into rows. By default, it will showcase year of order date, and you can just double click on orders count. You're going to get those results across year, how many number of orders have been placed, correct? And you can drill down, even you can showcase every quarter wise, even you can also showcase every quarter wise, month wise across that particular year. Clear? So I'm going to showcase all this information, but basically the point here is, in general, in the real time, whatever the data we are going to get, we have data across lowest level of granularity. But if you want to store the same data across highest level, yes, we have a flexibility that ETL team is going to take care of those calculations. If that is still not possible in the sense if they are not aggregated across the highest level, in Tableau, what I mean to say is we have a flexibility of these functionalities, right? This, whenever you're going to drag and drop, which is the data type, the data type is date. Whenever you're going to drag and drop order date into rows or columns, default, you're going to see year of order date. Or even we can also create calculations like year of order date. Even you can also create a separate field for year, or we can also use quarter. These functions, right? We can use some functions to aggregate the data across that level. So that's a functionality even we have in reporting side, or they have to taken care across while loading the data into data warehouse, they can create those calculations. That's what integration. So now integration is like aggregation, like summarize the data across highest level. Clear? So you may have data across city level, but whatever the cities you can aggregate and you can consolidate and you can showcase across state wise, and all the states you can aggregate and you can showcase across region wise, and we can also showcase the highest level across country wise, something like that. So but remember, basically we have data across the lowest level of granularity. That is what level of granularity, which is
Hello,
very
Ramesh.
important.
So
Yes.
I'm sorry to drag you back a little. So when you are on this board, these Excel sheets, it makes sense. But when you switch over to that Tableau and then you begin to drag things, I honestly don't know what you're doing there.
So what I'm explaining is it's simple actually. So no need to worry about Tableau. So we are not yet started, but I'm
Okay.
just giving an example like how the data
Okay.
looks like.
Okay. Okay.
Okay. This is
Okay.
what the regular data. Okay. This is what the regular date.
Mm-hmm.
So if you want to see like what actually how many number of orders placed in 2017, we don't have year column directly in our database. You can see, you can search for year. You don't have any column called as in a year in our database. What I'm saying is we have a flexibility in Tableau that if it is a date related data type, whenever you are going to drag and drop order date into rows, by default in Tableau, you are going to get year of order date. You don't want to even create any function. Okay. So, but
Okay.
this is the actual data. This is the actual data order date, but you are showing across year level. So at year level, how many number of orders? You can double click on count of orders to get the, or even sales. How many number of sales or how much sales happened across particular year wise. That is also possible. But we don't have year in our database. That's what I'm just showing the advantage of Tableau.
Okay. Okay. You are not yet teaching teaching Tableau, right?
Yeah. I'm not teaching any Tableau now. So we are
Okay.
still in the data warehouse, but I'm just
Okay.
comparing the results.
Okay. Great.
So if you want to aggregate, you can see 1, 2, 3, 6 records, more than 1,000 plus records. And it's very tough to do analysis each and every record. But users generally, right, the business users, generally they wants to check the data on a highest level of granularity, like year level. So I want to see year-wise sales. I know every day we are going to get some sales. Every day there are like different based on the business. We are going to have some different transactions. But on a high level, I want to check the data across year level so that I can compare current year versus previous year. That's what I mean to say. So we have 2017, 2018, 19, and 20. But when you look into this data, 2018 is less than 2017. But generally, right? That's what I mean to say this particular point, time variant, which we go for comparisons. If you have historical data, at least 3, 4 years of data, now you can compare the data, right? Like 2018 versus 2017, right? And 2019 versus 2018. That's what we have also done in the last class. So comparison of the data, basically, we'll look into that anyhow. But what's the important point here is integration is like summarized data. If you want to showcase across the highest level of granularity, we can use some functions. We can use functions, right, to aggregate the data across highest level, and we can showcase the data based on the user request. Sometimes they are going to say that, hey, can you please create year-wise sales? But when you look into this data, we search for year, but we don't have year column, and we'll go back to the team, the whatever the business team, or let's say any person like business, a BA person, right? Business analyst, or let's say a team lead who given the work for us. And he said to create year-wise sales report. And I'm searching for year column. I have sales column, but I'm searching for year column in this data. And I have a question, and I asked this person, hey, we don't have year column, but I can see a couple of dates, right? I can see a couple of date columns. We have ship date and order date. So which particular date I need to prefer to create year? You can ask that. If you're aware of that, we can create year functionalities on top of date related like date related columns. So I'm going to explain each and every point, but these data types are also very important. I can see with this data type, you can see this is the data type date, correct? If I'm going to convert into string, you can see year of order date, which is the date. That's the reason we are able to fetch year wise sales. But if I'm going to convert this into string, I can see I'm getting an error. The calculation year of order date applies a date function to a non-date field. Now I'm unable to create this. I'm getting an error, correct? So that's a problem here. If this is not the date data type, when you drag and drop order date, you can see you're seeing a regular date. You're not getting year of order date. But when you drop this, see the differentiation. When you convert into date data type, let's wait. When you convert into date data type, now when you drag and drop into rows, now you can see by default we are getting year of order date. That is the functionality of Tableau. That's the excellent flexibility where we have directly can showcase year-wise sales, or you can drill down to showcase quarter-wise. You can drill down to showcase month-wise. Even you can also create individual calculations that I'm going to showcase in the regular class. But this is just an example where we have data across the lowest level of granularity. But if we want to showcase the data across different level, yes, we can make use of like date related functions to aggregate or to roll up across year or quarter or month. Clear? So this is what actually data warehouse and the differentiation between OLTP versus OLAP. So let me know if you have still any questions.
Yeah, Rabash.
Yeah.
Can you display? Can you make an example of this OLTP system on Tableau? Like if they should
That's
give
a
you,
that's a
if
good
they should
point.
ask you, if they should ask you to present the data for 1 to 5 days.
Basically, just remember OLTP, we are not going to, that's a point I just given a border for this. We are not going to work on this particular area. We are not going to work on database, ETL and data warehouse. And we don't worry about the data. So let's say they are going to give access to the database. Let's say we have a database called as Oracle or SQL Server. We generally connect from Tableau. You can see you can connect from Tableau. Let's say if you want to connect to MySQL, we need to provide the database credentials, and let's say Oracle, you need to provide the server details connect, and based on the tables available or whatever the tables we need to work on, we are going to pull that particular tables here, and we are going to do the reporting. But no need to worry about OLTP systems. So basically OLTP systems or whatever the real-time data. So the ETL persons are going to track, and they are going to take care of this particular information. So that's
Okay.
what you don't worry about this particular portion. But this is very important to understand, because sometimes on a high level, so they will ask you what actually data warehouse and what is the life cycle of data warehouse, right? So mostly the business, mostly the client, in a client interviews, right, they will ask on a high level these type of questions. So what actually data warehouse, and how you are going to get the data. So we can tell that, hey, we have an application oriented systems, like we have OLTP systems, and ETL people, right? ETL developers, they are going to extract the data, and they're going to do some transformations, and they are going to load into one single database that is called as data warehouse. That simple point helps uh, so in interviews actually. So that these points are very important to at least to know the basics of data warehouse for interviews,
Okay.
because we don't work on this, right? We don't work on this, and we don't want to worry about this, but in interviews like we need to answer few of the basic questions so that they will feel okay, you have a better understanding of the data warehouse.
Okay.
So this is what data warehouse. Importantly, we have a few more concepts like we have a concept called as fact and dimension, and we do have fact tables and dimension tables. And importantly, we have a data modeling concepts like star schema and snowflake schema. So first we'll go through this what actually fact and dimensions today. And tomorrow's class is very, very important. So we'll discuss the data modeling concepts like star schema, snowflake schema. This is very important. I'll come back to this in detail. So what is a fact? What is a fact and what is a dimension? Any idea what is fact? Or we can also call it as measures or metric or KPIs. I'll come back to each and every point. What actually fact? And we have fact tables. So generally, when you look into this data, right? When you look into this data here, you have category, city, country, order date, products, and you can see region. But when you scroll down, you have discount, profit, quantity, and sales, correct? So you can see a region. When you select region, it shows in blue color, and when you select sales, it shows in green color. So basically we have a line separation. I'm going to tell that, but when you drag, whenever you are going to drag and drop any of the column, you can see a naming convention, right? Dimensions and measures, correct? So a line separation, and you can see a dimensions above all our dimensions, below all our measures. Okay, Control Z. So what I mean to say is these are measures. Basically in data warehouse terminology, we do call it as fact, and these are dimensions. So that's what the basic thing. If straight away I'm going to teach Tableau, you never know the differentiation, what actually region and what actually measures. You can see their separation with dimensions and measures. And if you're not aware of the basics, initially it will be a bit tough. So the actual terminology in the data warehouse is fact, but in Tableau, we are going to call it as measures. What is fact? The definition of fact is very important. A fact is a numerical value which can be aggregated and it impacts on the business. Clear? A fact is a numerical value. So fact must be a numerical value, okay, which can be aggregated. I'll tell you what actually meaning of aggregation, and which impacts on the business. Impact on the business, this is it's my definition. Basically I want to add this particular point, impact on the business. I'll tell you like what is the advantage of this particular point. But fact must be numerical value. Examples, we do have sales, profit, discount, quantity, we have salary, balance, account balance, subject marks, correct? So we have a lot of facts actually. So we do have a lot of facts or measures, depends on the business, correct? So whenever you're going to, I'm going to showcase examples as well, but we don't use in general like metric or KPIs as a regular terminology, but sometimes the business or the client side, right? Maybe sometimes they use the terminology called as what are your key metrics. It's the same key measures or key metrics or KPIs. KPI is nothing but key performance indicator. Key performance indicator. I'll give you a very good example here. So let me showcase here. So let's search for Wikipedia, anything, Wikipedia Walmart. In Walmart project, there might be a lot of measures, right? A lot of measures they're going to use in projects. But when you look into this, when you look into Wikipedia on a high level, they're showing some indicator, right? I do feel before COVID-19, I have seen this net income, operating income and net income might be less. It's in red indicator. But after COVID-19, I have seen Walmart sales has been increased. Number of location is decreased. You can see, and they might have stopped like servicing a few of the locations. They stop those stores. But you can see revenue, operating income, net income, total assets, total equity. What is the advantage of this is indicator is like, this is what indicator, which is in, which indicates that straight away you're seeing that in green color, which means, which is mostly like it's a comparison, maybe like current quarter versus previous quarter, right? And it shows that, hey, this is increased when you compare with previous quarter. That's what the point here. So these are key main KPIs. That is what key performance indicator. In projects, we might have lot of KPIs, lot of measures, but we don't call those measures as KPIs. Whatever the important measures, let's say sales and profit are very important. I can tell that, hey, these are the key performance indicators in my project. So just a terminology, but in real time, we are going to use measures. That is in Tableau, we do called as measures, right? As I said, you can see when you drop, because this is changed from 2020.2 version. We have a proper naming convention for dimensions here, and we have a separate tab for measures, but now they changed because just to give this information, like just when you drag, you'll get more clarity, but they just removed that naming convention. I'm not sure why they have removed. If they use the same proper dimensions and measures naming convention, maybe most of the people might understand, while initially whenever we are loading, whenever we are not loading, learning Tableau. So but still it's simple. Even you can identify this, you can see below the line or measures, above the line or all or dimensions. So this is sales. When you double click on profit, you can showcase profit. So that is what fact. A fact is a numerical value which can be aggregated. What actually aggregated? What are all the aggregate functions? Any idea about aggregate functions? Sum, average, minimum, maximum. Don't go for count. So you can use sum of sales, average of sales, minimum of sales, max of sales. But let me come back to one more point here. What we are saying is every numerical value is a fact, right? Is that correct? A fact must be a numerical value. but every numerical value is not a fact. Example of non-facts, right? We have account number. Account number. Account number is a pure numerical value, correct? Phone number. Phone number is also a pure numerical value. SSN. Employee ID. Most of the employee IDs, right? It's a numerical value. Some of the organizations, they might use some alphanumeric, but most of the employee IDs are numerical values, or some serial numbers or numerical values. These are not facts. These are not a fact. Account number is not a fact. Account number is a numerical value. Still, it is not a fact, because we are not going to add account number 1 plus account number 2. We are not going to add account numbers, right? Sum of account number 1 plus account number 2. We are not going to add phone numbers. It's not meaning. We are not going to get a meaningful data, correct? So non-facts, I'm going to tell you that in the dimension concepts, what is advantage of ID forms, ID columns or number. But remember that every numerical value is not a fact, okay? Let me give you a very good example here. Don't be confused. Anyhow, I'm going to explain that. As I said, these are measures, right? Which shows in green color, correct? Please stop me whenever you have any questions. These are measures, okay? Sales, quantity, profit, and discount. But what I'm going to do is, I'm going to create a simple field called as year of order date. Don't need to worry about these calculations functions, but basically year is a dimension, okay? Year is a dimension. I'll give you very good example here. I'll showcase the data so that you will understand. So when you create year, whenever you are going to drag and drop order date, what is the data we are getting here? 2017, 18, 19, and 20, correct? So these are the 4 years of data we do have in the sample superstore database. But I created a function, I created a year field by using a function called as year. Unfortunately, it comes under measures. This shows in a green color. When you double click, what I'm getting is sum of year, and it is showing some 201751110, which is not correct. We are expecting year is nothing but whatever the years we have to showcase that data, that is 2017, 18, 19, and 20. This is what the data I'm expecting. But what happened when you create year of order date function by using year of order date? Year is a numerical value, right? Year is a number data type, integer data type, 2017, 18. It's a number, correct? What Tableau recognizes, hey, this is an integer data type, and it loads. It's when you create a calculation, sometimes this is what happens. But when you load the data, 90% of the cases, it is going to separate what actually dimension and measure. But what we have to do with this, is that complicated to convert into dimension? No. If you're aware of year is a dimension, simply drag and drop here. That's it. Simply drag into dimensions. Above the line, you have a line separation. And now double click on year. I can see 2017, 18, 19, and 20. So this is a numerical value. Year is a numerical value, but it's not a fact. But sometimes we have to convert, but it is not a fact because year is a dimension. So every numerical value is not a fact. Remember that particular point. But measures has to be aggregated. You can see here, whenever you're going to double click on sales, default we are getting sum of sales, and you're getting proper data, correct? And it is going to aggregate. This is what the aggregation. Even when you use order date, this is the best example where we are we are aggregating. So let's drill down. Now this measure is aggregating across year level, correct? Sales we are getting across year wise, but when you drill down, you are getting the same sales aggregation across each and individual quarter wise, correct? But we don't have employee ID across year level. We don't have separate employee ID across each and every month level and quarter level. We don't get something like that. We have single employee ID across years. What I mean to say is, the example is, we don't aggregate the data on top of non-facts, something like this dimensions. We have employee ID, phone numbers, account numbers, or not a fact, it's a dimension. Okay, that's the reason I just used impacts on the business. I will give you a very good example here. Just try to understand, you'll get more clarity on this. Do you remember, like in the COVID-19 situation, a lot of jobs has been lost, correct? Let's say an employee have account number, correct? For sure, the employees have bank account, and every month, or depends on the in US, sometimes you generally get couple of weeks or weekly payment. But let's put aside that week level or month level. So what I mean to say is, employee is working for a particular organization in COVID-19 situation. Let's say for a particular employee, he didn't get salary for 1 month, correct? Let's say for 1 month he didn't get a salary, and employees are waited for 1 month. So that's not an issue. Let's say for 2 months the employees didn't get the salary. You have bank account, correct? You have bank account where you used to get salary, which is going to credit in for that particular account. But in terms of the situation is very bad, and the organization is in a loss, and they're not going to pay you the salary, right? And let's say you waited for 3 months, and the organization still in a loss, and there are like more than 1,000 employees who are not getting salary, and they decided that, okay, this situation is very bad and I need to quit this company, and I'm going to I should join another company. So then you're going to search for a job, correct? And you'll quit this job because anyhow you're not going to get salary. So the point here is, what is impacting the business? Salary, correct? You didn't get salary. You have account number, correct? But you don't get salary. Account number is important. I'm not saying account number is not important. Account number is important, but salary is going to impact the business, not account numbers. You understand, right? So if you didn't get salary, right, that's the impact on the business. Then anyhow we have loss because of COVID-19, because of the like the business, like no more transaction happened, no one purchased, or a lot of things happen actually. But for in terms of employee information, if the employees are not going to get salary, they are going to quit the job anyhow, then for sure this is going to impact on the sales and all those stuff, correct? So account number, when you compare with account number and salary, account number is important, but salary is going to impact the business. That's the reason I just used this particular statement. Fact is a numerical value which can be aggregated and which impacts the business. That is what very important. So I'm going to tell you what actually fact table. So mostly I will tell you fact table and dimension tables tomorrow. And quickly I will jump into dimensions, and anyhow I will recap, right? And what actually dimension, and let me know if you have any questions. I'll come back to these points anyhow, because when you double click, right, when you double click on profit, you're getting sum of profit by default, correct? Default aggregation is sum. But if you want to change, you say like you can go for different aggregation. Yes, you can go for different aggregation called as average. You can also showcase minimum of sales, max of sales, everything is possible. So that is what aggregation. So A fact is a numerical value which can be aggregated and which impacts on the business. Clear?
Sure.
So dimensions are simple. Dimensions which gives context to the fact. Okay. So what is meant by dimension is it's actually very important. Let's say when you double click on sales, what is happening here is we are getting grand total. Okay. Just the total sales. Without any dimension, what is going to happen is you can simply showcase the sales, total sales. You don't have any information. But when you place any dimension, let's say whenever you're going to drag and drop region, region is a dimension. Now you can showcase the same data across region wise. Then you can tell that, hey, this is what region wise sales, correct? This is what overall sales, but individual region wise you can showcase the data. Or let's say we have, like, let's say an employee, like we have salary information, salary, let's say 40k dollars, right? And this is the only information. It's not a complete sentence, right? So we should have some information, like at least whose salary it is. Now you can use employee like John. So we can tell that, hey, employee John salary is 40k, something like that. Just an example, right? So if you're not going to use a dimension, it simply showcase a grand total. Without a dimension, it showcases grand total. So that's the advantage of dimension. Dimensions which gives context to the fact. But importantly, try to understand this particular point. We have ID columns and description columns. Description or name. Okay. That's the reason I said, right, we have employee ID. Example, employee ID. Employee name. What is the advantage of employee ID? If we have already employee name, why should we use employee ID? Any idea? In general, when you join in any organization, they're going to create IDs, right? Why should we
Yes,
use
I guess
ID?
because, sorry to cut you. I guess because names, people can have the same name, at least like the first name or maybe the last name, but the employer ID is very specific. There can be
Perfect.
two employer IDs.
That's great. Yes. Thank you. So because of duplicate names, employee name might have duplicates, correct? Because of the duplicate names, so to identify a specific person, right? So then they are going to create a unique identification number, that is what employee ID, correct? And one more point I'm going to tell you that what is the advantage of ID forms, ID columns is for relationships. So for joins, specifically joins in terms of uh, technically speaking, we do call it as joins, but we do call it as to establish relationship between the tables, we are going to use employee IDs, not naming convention. Even you can also use employee name or even naming conventions or description columns. But I will tell you the drawback of naming conventions for joins. I'll discuss in detail tomorrow. So you're going to get more details on the basics of joins and how we are going to establish relationship between the tables. But we have ID columns and description columns. An example for dimensions, you have year, quarter, month, day. You can use day ID, month ID, or year, something like that. This comes under time dimensions or date dimensions. And we do have customer information, customer dimensions like customer ID, customer name, customer address, customer phone number, and let's say you have product information or geographical data. Let's take geographical dimensions like country, state, city, region, sorry. We have city IDs, cities, state IDs, everything is possible. We have product information, product dimension. These are examples, okay? We have our product ID, product name. We have this data actually. You can see product ID, product name, and you can see order IDs, customer ID, customer name, right? So those are the examples for like few of the dimensions, and we have categories, subcategories, all this information. But basically dimensions, very important. ID forms, I'm going to explain that tomorrow. So we have dimensions and measures, which we differentiated. So in Tableau we do called as measures, and few of the reporting tools we do called as metric. In general terminology we do called as KPIs. That is what I just explained, right? These are the important KPIs. It's indicate, right? Which indicates, you know, we have a speedometer, which indicates how much speed you are going on a car, right, by bike, so something like that, which indicates. So that is what KPIs, key performance indicator. And importantly for dimension, yes, dimensions are very important, which gives context to the fact. Let's say if you're going to drag and drop region, you're going to get region wise sales. If you're going to drag and drop state, we are going to get individual state wise information. And if you're going to use product, you're going to get product wise information. So that's the advantage of dimensions. So we'll look into these details tomorrow. So each and every point, these basics are important. Like that's the reason, as I said, right? And even, you know, data modeling concepts plays a major role, very, very important concept to understand what actually the star schema and the relationship between the tables. When you get clarity on this, then it will be simple to understand the data. So that's what the point. So mostly we'll start data modeling concepts tomorrow. Okay. So, and I will explain what actually fact table and dimension table. Anyhow, in the data modeling concepts, I'm going to cover each and every point. Clear all?
Yeah, it is clear.
Thank you.